Hey all my dear students, right now I'm going to give you the best trick to find out number of p pi or p pi d pi bonds. Just in 3 minutes, yes, the amazing trick. Now my dear students, this is really a question where people are doing mistake, but it holds a hell lot of weightage. Now my dear students, if I talk about when the pi bond is going to get formed. If I talk about first period, the first period is having two elements and that is involving filling of s orbital, and s orbital can never form a pi bond. Why s orbital can't form a pi bond? Let me tell you. S orbital is always spherical. There is only one lobe, and one lobe means it can never form a pi bond. 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 Whether it belongs to any of the subshell, the S can't form a pi bond, because for formation of pi bond, the parallel orbitals should lie above the plane and below the plane. The pi bonding is formation taking place at two places, and for that there must be two lobes. Now if there are two lobes, then it's not sure that it is going to form a p pi d pi bonding, because for that those orbitals should not be involved in hybridization. Now let me give you the thing one by one. So if I say that P and D, they can form a pi bond. They are having ability because there are two lobes. Both of these are having two lobes. So I will say they may form. They may form. So tick tick. Now if I say element belong to period number 2. So see, what are these elements? Boron, carbon, nitrogen, oxygen, fluorine. So all they are belong to period number 2. And in second period, D does not exist. So this D does not exist. So I will put a cross over here because D does not exist. Only 2P exists. If I say 2D, 2D doesn't exist. So the second period element may form pi bond. This may form a pi bond. This can never form a pi bond. Now, if I talk about period number more than 2, that means third period. If I talk about third period, fourth period, fifth period, so in third period D exists, 3D, 4D, like that. That means S will never form, but these two may form the p pi d pi bonding. Now how to find out, how to get it, that which one is forming p pi bonding and which one is forming p pi d pi bonding, and how many such type of bonds are there? So Simpson, let's move to the next page. If central atoms surrounding atoms from second period, then only that can make, then only p orbital can make, and if central atom surrounding atom is from period number greater than 2, then P and D both can make. This already have told you on the previous page. Now Simpson, come over here, H2SO4. Now my dear students, some day back I have given you the trick to find out the hybridization of any compound, the shape of any compound. So to find out hybridization, what is required? Just find out the hybridization. Answer is given over there, but how to find out this answer? We should know the hybridization, and to find out the hybridization, we should know the steric number of central atom. So let me form the structure of H2SO4. It's like this, and the central atom over here is sulfur. You can see how many sigma bonds are there: 1 sigma, 2 sigma, 3 and 4. So steric number is 4. That means the hybridization over here is sp3. This means that sulfur belongs to, sulfur belongs to third period. Why I'm saying it belongs to third period? Oxygen and sulfur. First period, second period, and third period. That means we know that all they are having one S, 3P, and how many D? 5D. So its S is involved in hybridization, and all the 3P, they are involved in hybridization. That means not, yes, none of the P is left. So D are vacant, sulfurs D are vacant, and oxygen belongs to second period. This belongs to second period and this belongs to third period. Its D are vacant, 5D orbitals are vacant, and its P are involved. So definitely this is and this is pi bond. Here is pi bond, here is pi bond. These are two pi bonds. So we will say there are two D pi P pi. P pi from oxygen, this is coming from oxygen, this is coming from oxygen, and that is coming from sulfur. This is from sulfur. And how many types? These are the numbers, this is the type, and these are 2 in number, 2 in number. I hope that is clear. Remember that the orbitals which are involved in hybridization, once the orbital is involved in hybridization, its one lobe will become bigger and another lobe will become smaller. But for formation of pi bond, P pi, D pi, or P pi, P pi, both the two lobes should remain pure. Pure means they should not get involved in the hybridization. Then we will say both the two orbitals are of equal size. I hope you got it. So one more example. Okay, sulfate. If I talk about sulfate, I will say its structure is S double bond O, O negative, O negative. Same, you can see the previous structure, it is having two P pi and D pi. P pi from oxygen and D pi from sulfur. I hope this is clear. This is from oxygen because oxygen belongs to second period, and this is from sulfur. Sulfur belongs to third period. So my dear students, here is your answer. Now let me tell you one more. HCOF, HCO4. This is belong to zero group noble gas, but xenon forms bond with oxygen or fluorine at high temperature and pressure. That's none of your business. Let's see xenon. Let me write down xenon double bond O, double bond O, double bond O, double bond O. Xenon is having 8 electrons in the outermost shell, but out of these, 1 sigma, 1 more sigma, 1 more sigma, 1 more sigma. So steric number is coming out 4. So the hybridization is coming out sp3. Now xenon belongs to C: helium, neon, argon, krypton, xenon. No need to go over there. It's more than second period, so it is having d orbital. And definitely sp3, all p are involved in hybridization, so d orbitals are vacant. So I will say oxygen will always form p pi because it belongs to second period. So 1, 2, 3, 4 xenons d pi, and oxygens p pi. So how many such type of bond? 1, 2, 3, 4. There are 4 d pi p pi bond. So I hope this is very much clear to all of you. Always write down the compound, then see the central metal atom or non-metal, whatever central atom is there, find out its hybridization, and if any element is belonging to second period, it can always form only p pi. But if element is belonging to onwards of second, that is third, fourth, then it is having ability to form p pi as well as d pi. When p pi will come, suppose if any element is belonging to third period, then when it will form p pi, once the hybridization is either sp or sp2, that means its p orbital is still vacant. Now one question for your homework. Everyone, do let me know the answer of this question in the comment section. So I hope that this must have helped you. Bye bye, take care.